Hi my dear students, this is Murthy. Welcome back to Raghav Math e-learning. In today's class, we are going to discuss about sandwich theorem or squeeze theorem and its applications. Let's get started. See here, the statement for this sandwich theorem is, suppose f of x less than or equal to g of x less than or equal to h of x and limit x tends to a f of x is equal to limit x tends to a h of x is equal to L, then limit x tends to a g of x is also L. Okay, so here what information is given and what we have to prove once you observe, that is, they have given f of x less than or equal to g of x less than or equal to h of x, and also they gave limit x tends to a f of x is equal to limit x tends to a h of x are equal, that is L, is it? So we try to draw the graph for this information, is it? So we try to draw the graph for this. Listen carefully. Here you see that, suppose I am taking first f of x graph, is it? So here the f of x graph, suppose I am taking the f of x graph maybe like this. Okay, it is graph of what function? I have taken it is y equal to f of x, and I am going to take this is a. Okay, at a the functional value is suppose m. So here you tell that what I have taken, limit x tends to a, I mean x approaches to a, then this function approaches to what? That is L. So x approaches to a either from right side or left side, the function approaching to the number L, is it? So limit x tends to a f of x is equal to L. Okay. Now I am going to draw the graph for h of x. Which function? H of x. See here what given? F of x is less than or equal to h of x in the neighborhood of u. So here f of x less than or equal to h of x. So f of x is below to h of x, is it? So below to h of x means, see, suppose if I take the graph like this, is it correct? No. Why? Because here they have taken limit x tends to a h of x is also what? L. So you can't take the graph like this, is it? Why? Because limit x tends to a h of x also L means if x approaches to a, the function h of x also approaching to same number L, is it? That is the reason we can't draw the graph like this. So I can take the graph like this, is it? Can I take it? Now you see that what is limit x tends to a h of x? Yes, it is y equal to h of x. So limit x tends to a h of x is equal to L, is it? Now we try to draw the graph for g of x, is it? See, g of x is in between f of x and h of x. So g of x is in between f of x and h of x. So no doubt at all, the curve may be like this. Is it? Can I take like this? Yes. Why? Because g of x is in between f of x and h of x. So it is y equal to g of x. Now can you tell that what is limit x tends to a g of x? Yes, no doubt at all. That is also what? L. So this is sandwich theorem. I mean f of x less than or equal to g of x less than or equal to h of x and limit x tends to a f of x is equal to limit x tends to a h of x equal to L, then limit x tends to a the middle function is also L. So this is the function f of x and this top one, that is h of x, and the middle one g of x. So limit x tends to a f of x and limit x tends to a h of x are equal, then limit x tends to a that middle function is also what? That is also L. Is it clear? For some functions, we are unable to evaluate the limit at some values. Then, if you can exist or if you can find any two functions so that f of x less than or equal to g of x less than or equal to h of x and limit extends to a f of x is equal to limit extends to a h of x equal to L, then you can take limit extends to a the required function g of x is also L. Is it? See, so to get that form, we want one inequation. Here you see that limit extends to infinity step x by x. So we are unable to evaluate this directly. That is the reason I am going to use sandwich theorem. But to use sandwich theorem, I want one inequation like f of x less than or equal to g of x less than or equal to h of x. So we have one inequation with this step function, that is x minus 1 less than step x always less than or equal to x. So for all real numbers this is correct. You must remember that here x minus 1 less than step x less than or equal to x. So to apply this sandwich theorem, to get the limit, I am going to use this inequation. So we have x minus 1 less than step x less than or equal to x. Okay. So here which function we want, that is step x by x we want. So for what function you have to find limit, you have to put that function at middle. Is it? So at middle I want step x by x. So divide this inequation with x. Is it? So divide with x. But here this is inequation. If you divide this with positive value, no change in inequation sign. If you divide this with negative value, inequation sign changes. Is it? So here we are going to divide this with x. Is x positive number or negative number? Here you observe. So given that x approaches to infinity, x approaches to infinity means is x a positive number or not? Yes, x is very larger number. So is it positive number or not? Yes, no doubt at all, it is positive number. That is the reason no change in inequation signs. So you can write it as x minus 1 by x less than step x by x less than or equal to x by x. Is it? Now you take this is function f of x and you take this is function h of x. Is it? And this is the function g of x. Is it? So first you find the limit for the function f of x at infinity. Is it? So limit extends to infinity f of x. What is it? X minus 1 by x. Is it? You know how to evaluate limit for this type of functions. I mean, if there is extends to infinity, then we observe degree of numerator and degree of denominator. Based on that we can give the answer. What is degree of numerator? Power is 1. So 1. Degree of denominator, that is also 1. So degrees are equal. If degrees are equal, answer is ratio of their coefficients. Is it? So here x coefficient 1 by 1. Is it? So it is 1. And limit extends to infinity. What is this? It is x by x. Is it? So what is it? Anyhow it is 1 only. See, limit extends to infinity f of x is 1. Limit extends to infinity h of x is 1. So from sandwich theorem, limit extends to infinity step x by x is also what? Is also 1. So answer to this problem is 1. Coming to second one, we have to find limit extends to infinity step ax plus b by x. So we are unable to evaluate it directly. Again, I am going to use sandwich theorem. But to use sandwich theorem, we have to take f of x less than or equal to g of x less than or equal to h of x form. Is it? So we have one inequation with step function. What is that inequation? That is x minus 1 less than step x less than or equal to x. So I am going to use that inequation again. See here. In place of x we have this. Is it? So you can take that ax plus b minus 1 less than step ax plus b less than or equal to ax plus b. Is it? So for which function you have to find limit, you have to put that function at middle. So we want step ax plus b by x. So you have to divide this with x, is it? So here divide with x. But when you divide with something, you must be very careful. So if you divide with a positive number, no change in equation sign. Here x approaches to infinity. Infinity means very very larger number. So is x positive or not? Yes, x is positive. So what we can get? That is ax plus b minus 1 by x is less than step ax plus b by x less than or equal to ax plus b by x. Is it clear? Yes. Now this is the required function which is at middle place. Is it? So this is like something f of x less than or equal to g of x less than or equal to h of x form. Is it? So we find the limits to first function and last function at infinity. So limit extends to infinity ax plus b minus 1 by x. So how to find the limit? So here degree of numerator is 1, degree of denominator is 1. So both degrees are same. So limit value is ratio of their coefficients, that is a by 1, that is a. Coming to last one, that is limit extends to infinity ax plus b by x. Again same story. Here degree of numerator is 1 and degree of denominator is 1. Is it? So limit of this function, that is again ratio of their coefficients, that is also a. So by sandwich theorem, here we have limit extends to a f of x is a and limit extends to a h of x is a. So limit extends to infinity, that g of x, I mean here limit extends to infinity f of x is a, limit extends to infinity h of x is a. So limit extends to infinity, the middle function, that is the required function, is equal to a. Is it clear? So limit of this function is what? Limit of this function is a. See here, now we are going to evaluate limit extends to 0 x into step 1 by x. So for this also we are unable to evaluate it directly. Again I am going to use the sandwich theorem. So for that we have to take the inequation. Again we have step function, so we use that step inequation. What is that? So here in place of x we have 1 by x. So 1 by x minus 1 is less than step 1 by x is less than or equal to 1 by x. Is it? So we have the inequation, that is x minus 1 less than step x is less than or equal to x. So I use that. Now here you have to take the required function at middle. Is it? So you have to multiply this with what? X. But here the important thing is, if x is positive, it's not a problem. There is no change in inequation sign. But x is negative, inequation sign changes. Is it? So here I am going to find right limit and left limit. So first I am going to take limit extends to 0 plus x into step 1 by x. So I have taken extends to 0 plus. Means what? X greater than 0. Means x is positive. Okay. Now multiply with x. Multiply with x. So what we get, you see. Now in this case, is x positive or negative? Yes, x positive. So no change in inequation sign. So what we get? That is x into 1 by x minus 1 is less than x into step 1 by x is less than or equal to x into 1 by x. Is it? So what is it? It is 1 minus x is less than the required function is less than or equal to 1. Is it? Now this is function f of x and it is the function h of x, and middle we want this, it is g of x. Now you take that limit extends to 0 plus f of x. So limit extends to 0 plus 1 minus x, it is 1, and limit extends to 0 plus h of x. That is limit extends to 0 plus what is h of x? That is 1. So it is 1. Is it clear? Yes. Now limit x tends to 0 plus f of x is 1 and limit x tends to 0 plus h of x is 1. So limit x tends to 0 plus x into step 1 by x is also 1. Is it? Now we find the left limit of the function at 0. So here x tends to 0 minus means x less than 0. Is it? So again here you have to put the required function at middle. So you should multiply with x again. Is it? So here x is negative. So if you multiply with x, in equation sign changes. Is it greater than? X into step 1 by x is greater than or equal to x into 1 by x. Is it? So what we got, you see, that is 1 minus x is greater than x into step 1 by x is greater than or equal to 1. Is it? So can I write it as 1 less than or equal to x into step 1 by x is less than 1 minus x. Is it? Now this is like f of x and here it is g of x and here it is h of x. So limit x tends to 0 minus f of x. What is f of x? That is constant, so 1 only. Limit x tends to 0 minus h of x. What is it? 1 minus x. So again it is 1 minus 0, that is 1. So from sandwich theorem you can take that limit x tends to 0 minus x into step 1 by x is 1. Okay. Already we found right limit, we got 1. Now we found left limit, we got 1. Is it? Thus limit x tends to 0, x into step 1 by x is what? Is 1. Is it clear? Moving to next. Limit n tends to infinity, step 1x plus step 2x plus so on plus step nx by n square. So here we are unable to evaluate it directly. Again, I am going to use sandwich theorem. But to apply sandwich theorem, we want one inequation. Is it? So with step functions, we have one inequation. Is it? So here step 1x, step 2x, so on, step nx. Okay. So in general, I am taking that is step rx. Okay. You take the inequation with step rx. Then what is it? Rx minus 1 less than step rx is less than or equal to rx. Is it? See here. For which function you have to find the limit? You should take that function at middle. Is it? So here what I want? I want step 1x plus step 2x plus so on plus step nx. So you apply sigma. I mean we can take it as sigma r equal to 1 to n rx minus 1 is less than sigma r equal to 1 to n step rx is less than or equal to sigma r equal to 1 to n rx. Now once you observe the middle function, what is this? First r value 1. So step 1x. Yes. Sigma plus step r is 2x plus step 3x plus so on, at last r is n, step nx. So we got the numerator at middle. Is it? So you should divide this with what? N square. Is it? Yes, anyhow that n square is positive only. So now divide with n square. Divide with n square. Listen carefully. Here we can get sigma r equal to 1 to n rx minus 1 by n square is less than sigma r equal to 1 to n step rx by n square is less than or equal to sigma r equal to 1 to n rx by n square. Is it? Just you do the simplification. So here you expand it. What we get, you see, first 1x, 2x, 3x, so on, nx. Is it? So it become what? X into 1 plus 2 plus so on plus n minus r equal to 1, it is 1. R equal to 2, again 1. R equal to 3, it is 1. Is it? It is independent of r. Is it? So every time here we get 1, 1, 1, 1. Is it? So how many ones you can get? N ones. So minus n. By what? By n square. Is less than, coming to this. So same function you can get. Is it? If you expand this, you get this function. Is it? Suppose we name it as g of x is less than or equal to, here take r1, r2, so on, rn, and you take x common. You get 1 plus 2 plus so on plus n by n square. Is it? Now here we got f of x less than g of x less than or equal to h of x. Is it? Now you have to take the limit. So here what given? Limit n tends to infinity. So limit n tends to infinity this f of x. Is it? So what is it? X into what is 1 plus 2 plus so on plus n? You know that n into n plus 1 by 2 minus n whole by n square. Is it? This is equal to, listen, limit n tends to infinity this function. What is degree of numerator? N into n, n square, so degree 2. Denominator, n square, degree 2. So degrees are same. So what is the limit value? Ratio of their coefficients. So what is n square coefficient? So n square coefficient is x by 2. Is it? Here n square coefficient is 1. So totally what we got? We got x by 2. Is it? Coming to limit n tends to infinity this h of x. So x into what is 1 plus 2 plus so on plus n? N into n plus 1 by 2 n square. Is it? Now again you have to evaluate the limit. What is degree of numerator? N square. So 2. Degree of denominator also 2. So what is the answer? Answer is ratio of their coefficient. So here m square coefficient x. In this m square coefficient 2. What is the answer? Answer is x by 2. See what happened? Limit n tends to infinity this function is equal to, limit n tends to infinity this function is equal to x by 2. So limit n tends to infinity the middle function is also x by 2. Is it clear? So final answer is x by 2. Is it? My dear students, I think you understood this concept. Here we have one shortcut method to give the answer easily for some problems. That is, if the problem is like this, I mean limit n tends to infinity step 1 power kx plus step 2 power kx plus so on plus step n power kx by n power k plus 1. Then answer is x by k plus 1. Here you observe the first one. Just now we evaluated this limit and we got x by 2. Listen, here it is like step 1x plus step 2x so on plus step nx. Here power is what? 1. Is it? So k is what? That is 1. By n power, so here power is 1. So in denominator it should be power k plus 1. So it will be here 1, so it is 2. Then answer is what? X by power in the denominator. That is x by k plus 1. Is it? So here it is answer is x by 2. Coming to this problem. Suppose the problem is like this. Limit n tends to infinity step 1 square x plus step 2 square x plus so on plus step n square x by n cube. So here squares we have. In denominator cube. Yes, it's correct. So answer is what? X by this power, that is 3. Coming to this. Here we have 1 cube, 2 cube, so on n cube. In denominator we have n power 4. So what is the answer? That is x by power in the denominator, that is 4. My dear students, if you feel it is worth, share this video with your friends and subscribe to my channel and click the bell icon to get latest notifications. Thank you.